I'm working on a surgical robotics project. I'm trying to build a robot that can drive a catheter to do cardiac surgery. There's a couple of products that exist out there, and I'm trying to work on the next generation of catheter robots so that we could really do some really interesting, cool, and novel stuff inside a beating heart and really enable surgeons to practice their procedures better.
I work on small-scale robots, specifically walking robots. A lot of small walking robots these days are modeled after cockroaches, which have very rigid bodies and only 6 legs, whereas my robot is modeled after a different arthropod, which is a centipede, which has a very flexible body and many legs. My project actually started because I found a centipede in my apartment when my roommate and I were watching iRobot, of course. And I saw how fast they moved and how agile they were, as we experienced when we couldn't actually catch the thing. And so I thought that would make a really cool robot and be an interesting way of locomotion to study. I do research to understand how to integrate flexibility into the body to make it move efficiently, and also study how to coordinate the many legs and what different advantages that body morphology can give us.
So my research focuses on using advanced manufacturing techniques that are very much inspired by printed circuit board manufacturing to build sort of a new generation of millimeter scale medical devices with integrated sensing and actuation modalities automatically built into it. So it's a technique called pop-up book MEMS, which was innovated here at Harvard in Professor Robert Wood's microrobotics lab to build flying robotic insects. And I'm looking at translating this technique into sort of the medical regime to enable it to build tools and devices that could go on the tips of catheters or the tips of laparoscopic tools and enable basically surgeons to do things that they can't currently do with their current tool set.
I got involved in this research when I came here as a graduate student. When I was looking for grad schools, I heard about this project and I just thought it was the coolest thing. Being able to compensate for heart motion and build robots just sounded really fun. It sounded really interesting. I knew that I would learn a lot, and I knew that in the end my efforts would make a pretty significant difference in terms of where medical technology has been in the past and where it will be in the future.
Harvard has sort of a unique approach to biomedical research, especially translational research. So the university's affiliation with the Wyss Institute for Biologically Inspired Engineering sort of brings together graduate students such as myself, professors, clinicians, experts from industry and academia to sort of support translational research that's going on here at Harvard. And this is great for somebody like me because the SEAS and the Wyss Institute has very well-established connections with clinicians in the Boston area and the Harvard Medical School. So for someone like me, if I'm working on a medical device and I want to learn more about a procedure or go maybe watch a surgeon live in the OR, and all I have to do is pretty much walk down the hall and talk to somebody or shoot out an email, and I'm in the OR the next week. So I think robotics in general is probably more ubiquitous than some people realize. I mean, you have your industrial robots that sort of weld and assemble and paint your automobiles. You have your deep sea rescue robots that can access areas that aren't permissible to human life to go either exploring or go into volatile environments such as like after an earthquake or a tornado or something of that nature. I mean, you have your medical robots, which are starting to sort of penetrate the commercial market in terms of medicine that can, pretty much augment a surgeon's capabilities. You have telepresence robots, which can enable basically remote access to patients at the bedside. You can get expert opinions from a surgeon who's, a continent away.
It definitely helps me wake up every morning and get into lab on the hottest and on the coldest of days, knowing that the stuff that I'm trying to work on could eventually be really, really life-saving for some people.